All right, so section 8.5, part B, partial fractions. Okay, and yesterday we went over a problem, or not yesterday, but the day before yesterday, we went over the following problem. Okay, so let me write this out. I wanted to do a partial fraction decomposition. We did one of them, and it looked kind of like this, but just that I'm going to write this a little different. I'm going to want to integrate 1 over x squared minus 5x plus 6 dx. Now, if you look at the previous notes, we actually did a partial fraction decomposition of that one. Okay, so I want to do it again. I'm going to do it kind of quick because you guys already have the notes for this. But I want to show you how I would go about doing this problem. So again, you guys already have these notes of how to break it down. So I'm going to go through it real quick. So you start off with your integrand on the inside. I notice I cannot integrate that using a u substitution because I would need an x to the first power on top when I do my u substitution. So I don't have that. So I have to think of a different way. So I go with partial fraction decomposition. So I factor my function here. So there it is. Okay, so that's factored. Once it's factored, then what I do is I start to rewrite it in terms of a's and b's. In other words, I get one of my factors and I write it like that, and then the next factor I write it like this. And yes, there's going to be a plus in the middle all the time. Now it might change once we get our answers, but it is going to be there the first time. Okay, you can have a plus. Now once you have that, you rewrite your problem. Now I usually rewrite it in factored form, meaning I write 1 over x minus 2 times x minus 3 is equal to a over x minus 2 plus b over x minus 3. And what I do is I multiply every single term by the LCM. Okay? I multiply everything by x minus 2 times x minus 3. When I do that, I get the following. 1 equals a times x minus 3 plus b times x minus 2. And again, yesterday we went over this, or the day before yesterday on Monday, no, Tuesday, we went over this. So just look at your notes from there so you can see like how we canceled stuff out. Now, once we get to this point, you got to start doing your let statements. Okay, your zeros. You're trying to find your zeros. So what makes x minus 3 a 0? Well, a 3 does. And what makes x minus 2 a 0? A 2 does. Okay, again, all of this is in your notes from before. So I plug this in. I get 1 equals to a times 3 minus 3 plus b times 3 minus 2. This comes out to b equals 1. Well, good. I found b. Now I plug in a 2 for a. So if I plug in a 2 for a, I get, if I plug in a 2 for x, I get 1 equal to a times 2 minus 3 plus b times 2 minus 2. So this comes out to negative a is equal to 1, or a is equal to negative 1. Okay, now all of this work right here, okay, this is not my answer, but I'm going to kind of put a box around it. Okay, this is my work that I do for the partial fraction decomposition. So I'm going to put work for decomposition. All right, that is not the answer. Excuse me, but it is a lot of work that I need in order to do the problem. Once I know what A and B are, then I can do the following. I can say, okay, this problem here is equal to the integral of, now my a term, remember I'm looking at this part right here, okay? This part right here. My a term is a -1, and my b term is a +1. So I'm going to write -1 over x minus 2 plus 1 over x minus 3 dx. Okay, now that's 2 u substitutions. Now I can do that in my head because I'm so used to doing these, but you may not be. So let me show you what it's going to look like. You might want to break them apart. So minus integral of 1 over x minus 2 dx plus integral of 1 over x minus 3 dx. Okay, so we're going to do 2 u substitutions, and I'm going to break my rule. I usually don't like to use u twice, but I'm going to do it just for this case here. Let u equal to x minus 2, so du is dx, and then over here, this hurts me to write, but I think for most of you guys this will make a little bit more sense if I just kind of keep it simple. So we're going to let u equal to those two things, but we're just going to pretend they're two completely different problems and completely different sets of problems, so they have nothing together. Normally what I would do is I'd tell you to let w equal to x minus 3, so dw is equal to dx, okay? But for now, let's just do that. If that's the case, then this is what it's going to look like. Integral of negative 1 over u du plus the integral of 1 over u du. What's the integral of 1 over u? Anybody say that out loud? Anybody remember the integral of 1 over u? Yep, well, ln of u, yes. Yeah, absolute value, right? So negative ln, all right, so it's going to be negative ln of the absolute value of u plus, this is ln of the absolute value of u plus c. Now, can you understand why it's not good to use u twice? Because which u goes where, right? Right? It's best to kind of keep it in w's and stuff, but if you can keep your work in order, then that's fine. But right here, it can start to get really complicated. So this would be an x minus 2 here, and the other one would be an x minus 3. Now, using the properties of natural logs, if it's a subtraction, it belongs in the denominator. If it's an addition, it belongs in the numerator. So therefore, this answer should be ln of the absolute value of x minus 3 over x minus 2 plus c. And that would be your solution to this problem. I'm going to do that just to make sure it makes it obvious that that is your answer, not the big box, but that one right there. You guys have any questions on this one? So notice the work for the decomposition, we did that on Tuesday, but I just kind of wanted to show you again because I wanted you to see what a whole problem looks like for these. Okay. Now you guys are lucky. In Calc BC, they only require you to do this with linear functions. When you do quadratic functions, it gets a lot more complicated. They only make you do linear stuff like this. Okay. But even linears can get a little tricky. We're going to do an example too, our last example. And that one's a little bit tricky. Not like super difficult, but you have to understand where we get our factors from. Let me see. I'm just looking at something. Yeah. So sometimes they can get a little bit tricky and people get a little confused. So we're okay? All right, so you guys can use your thumbs up things and stuff if you want to. It's going to sound kind of weird for people who are watching this video because they're going to be like, what is he talking about, thumbs up? Like, I don't see what he's saying. Yeah, that's not on the screen. All right, so here we go. Example number 2. So we're going to integrate, where is that? Integrate 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x dx. Now, you might be saying like, man, you jumped from something that looked pretty easy to something that looked pretty complicated. Well, that's kind of the idea, right? You're either going to get easy problems or you're going to get hard problems, okay? So I want to make sure you get to see both. Now, this looks a lot more complicated than it really is, but like I say, for the first time that you see it, it does kind of look kind of hard, okay? So we'll kind of go through it. We'll deal with it and we'll figure some stuff out. Okay? So all that matters when you do a decomposition is the denominator. Okay? That's what you're looking at. So let's factor out this denominator. So here we go. We got x cubed plus 2x squared plus x. Now I can factor out an x. That gives me x squared plus 2x plus 1. And then x squared plus 2x plus 1, that's an easy factor. That's a x plus 1 times x plus 1, which is x times x plus 1 squared. Okay, so there's my factoring of the bottom. Okay, so once I do that, I come back and I'm going to write 5x squared plus 20x plus 6 over x times x plus 1 cubed equals to. Now, I want to show you guys something really quick on the previous problem before we do this one. Well, I'm sorry, I said squared. I think I put cubed. Sorry. Squared. You notice I had two factors, okay? Both of them to a first power, just so you guys know. That's even more important. It's x minus 2 to the first power and x minus 3 to the first power. I had two factors and I introduced two letters, A and B. Two factors, two letters. Okay? So according to that pattern, if I had two factors, I get two letters. This one should also just have two letters, x and x plus 1 squared. Okay? But there's a rule. This is what makes this the harder one. The rule states that if your factor, one of your factors, is a composition, so notice this factor here is a linear function inside of a quadratic function, right? So it's still linear, but it's inside a quadratic. If you have that, then you count it as 2. Okay? There are two parts in there. There's an x plus 1, okay? And then there's an x plus 1 squared, okay? So the x plus 1 without the power and then x plus 1 with the power. So you're going to write it like this, a over x, because that's one of the factors, plus b over x plus 1, because that's the linear part of that composition, and then c over x plus 1 squared, because that's the quadratic part of that composition. Now, you might say, well, Mr. B, I just heard you say that we weren't going to do quadratic portions. They don't want us to do that on the BC test. That is 100% correct. This is not a quadratic type problem. It does have a quadratic power, but the function on the inside is still linear. It's once the functions on the inside are quadratics, like an x squared plus 2x or something like that, or an x squared minus 4. When that happens, then this occurs. You get like cx plus d on top and stuff like that. Like that's just, no, we don't want to get to that point. Okay, we just want A, B's, and C's. Okay, so we're doing linears even though there's a power of 2. So notice in this case, we're going to have to solve for 3 different variables, A, B, and C. Okay, in order to do that, I need to multiply everything by the LCM. And again, that's kind of easy. The LCM is the factor on the bottom, so it's x times x plus 1 squared. So notice on the left side of the equation, it's just going to cancel out the whole denominator, and I get 5x squared plus 20x plus 6 equal to, now on the next term, the a term, the x's will cancel, so it'll be a times x plus 1 squared plus, on the b, I'm going to have an x left over and 1 x plus 1 left over. And on the c portion, I just have an x. Okay, when I multiply everything out. Are we okay with this? I mean, as usual, this is just algebra. We're just doing algebra, guys. No calculus yet. Okay, if you look at example 1, the calculus did not hit until we got to this point, pretty much. Everything else was all algebra. Okay, so we're just working on algebra right now. Don't let that scare you off. Okay, so here are my let statements. If I want to solve, I'm going to let x equal to -1 because that'll make the x plus 1s disappear. Okay, and I also want to let x equal to what else? What else will make it equal to 0? What else is going to make it a 0? Anybody tell me? Like if I let x equal to -1, the x plus 1s become 0. What makes the x's become 0? And you can type it if you want, or just shout it out. Yeah, it's just 0. That's why I'm waiting, and you guys don't see my face, but it's like cringing because I'm like, really? You guys can't do the 0? I'm like, I gave you the easy one. So yeah, it's just 0, right? So let's do the -1, okay? If I plug in -1 into my function, it's going to look like this. 5 times -1 squared plus 20 times -1 plus 6. That's this part right here, okay? I'm plugging it in because it is the equation. I got to plug it into that equation. And then if I plug in a -1 into the x plus 1 squared, that's going to cancel out, right? So I'm going to try to write kind of small here. -1 plus 1 squared plus b times -1 times -1 plus 1 plus c times -1. Well, look, this is gone. This is gone. So the left side, I get a 5 minus 20 plus 6. Okay, so I'll get a 5 minus 20 plus 6. Yeah, that would be a -15. So that's going to give me a a 9, I think, right? It's going to give me a 9. That's negative. And then this will be a -c. So that means that c must be 9. So I figured out what c is. C has to be 9. Now, if I let x equal to 0, let's see what we get. 5 times 0 squared plus 20 times 0 plus 6 equals a times 0 plus 1 squared plus b times 0 plus 1 plus c times 0. Well, this all cancels. All right, so all I got is 6 equals a. So a is equal to 6. Here's the part that really gets to people, because we found a and we found c. Now we got to solve for b, but you have to ask yourself which values of x make it 0. We already exhausted all of them. we exhausted all the values of x that we can use to zero stuff out. So what do? Well, you improvise. You say, all right, let's let a equal to 6, c equal to 9, because we solved them, so we know those are true, and let's just pick any number that we want. So I'll pick x equal to 1. Because if I let a equals 6 and c equals 9, then there's going to be only one variable that I get, and x equal to 1, then there's only one variable left. There's just a b. Right? So let's do that. So if a is equal to 6, I'm going to write down, and c equals 9 and x equals 1, I'm going to write 5 times 1 squared plus 20 times 1 plus 6 equals a, which is 6 times 1 plus 1 squared, plus b, which I don't know. X is 1, so times 1, 1 plus 1, plus c, which is 9 times 1. I know it looks kind of messy. I'm just plugging stuff in. 5 plus 20 plus 6 is 31. 1 plus 1, that's 2. 2 squared is 4 times 6, that's 24. Plus 2b plus 9. Okay. Well, that's 31 equals 33 plus 2b. Negative 2 equals 2b. So b is negative 1. Now, I just want you guys to know, take a nice deep breath. We haven't even started doing the problem yet. Okay? All of this has just been decomposition. Okay? We just found our ABCs for this one. Okay? So, again, I'm going to highlight this thing. This is just the decomposition. This isn't even the main problem. But without this, you can't do the main problem. So work for decomposition. Funny enough, usually a lot of people don't mind doing problems like this. They just don't like the amount of work, but they don't think it's terribly difficult to do. But most people don't really mind doing the work. So here we go. Let's get to work here. I'm going to kind of stay zoomed out a little bit, okay? So this is equal to. Now, remember, I'm going to focus on this part right here. Okay, I'm going to focus on the breakdown, the ABC portion, because I know my ABCs right there, so I can do that. So I'm going to integrate. My A is a 6, so it's 6 over x. Plus, my B is a negative 1, actually it should be a minus. Minus 1 over x plus 1. Now those are really easy to do in your head. Once you get good at this stuff, I mean, you can do that in your head, no problem. And then c was 9, so plus 9 over x minus 1, was it minus 1? Oh no, plus 1 squared dx. Now let me break those apart. This is 6 integral of 1 over x dx minus integral of 1 over x plus 1 dx plus 9 integral of 1 over x plus 1 squared dx. All right. Now we know the integral of 1 over x dx. That's just ln of absolute value of x plus c. Right? Actually, hold on. Did I put plus c? Okay, good. I was getting a little worried. I thought I forgot to put plus c at the end of my problem. But no, I didn't. So the very first part is 6 ln absolute value of x, okay, minus, can someone tell me what the integral of 1 over x plus 1 dx is? I'm going to give you a couple seconds here. I don't know if anybody can do that in their head. It's just a u substitution. You let u equal x plus 1, du is dx. You can type it out if you want. I'll give you 10 more seconds if anybody wants to say it or tell me like, hey, I'm working on it. All right, so if you didn't know how to do it, let me just do it really quick. You're going to let u equal to x plus 1, so du is dx, so your integral is 1 over u du, which is ln of absolute value of u plus c. So it's basically ln of x plus 1 in an absolute value plus c. So this part is ln of the absolute value of x plus 1. The last part for us right here, it's just basically a u substitution again. Okay, so let's use w. Let w equal x plus 1, so dw is dx. So this is 9 integral 1 over w squared dw. Okay, so I'm going to kind of skip a little bit here. So we got ln of x to the 6th. Notice I do not have the absolute value anymore because if x is being raised to the 6th power, it's going to be positive, so I don't need to keep it positive. Minus ln of absolute value of x plus 1 plus 9, and the integral excuse me, of w to the negative 2 is negative 1 over w. Okay, and then plus c. So let's plug everything back in here. Ln of x to the 6th minus ln of absolute value of x plus 1. I should probably make that look more like a 1. Minus 9 over x plus 1 plus c. Now you might want to combine those natural logs because usually they do. So this is ln of x to the 6th over x plus 1. I know I put it back in the absolute value. It doesn't hurt if you do. It's fine. Minus 9 over x plus 1 plus c. So this is a lot of work, okay? I know it's a lot of work. I mean, let's zoom out just to give you a good idea, okay? But it's work you guys should know how to do. The algebra, guys, this part should not be like, oh my gosh, I've never seen this before. This is algebra 1 and 2, basically, right? When people say, why do we have to take algebra 2? Because it's algebra 1, but it's more difficult. Well, this is algebra 2 right here, like going through and figuring out zeros. That's what you do in algebra 2, right? And then once we get to the integral part, this breakdown, this piece right here is basically the main step in partial fractions. Like you have to write that out. After that, like this, in other words, what I just circled, that's the only thing that's brand new that you guys have never seen us do before. Because after that, we just integrated. That's chapter 4. Okay? This isn't, well, maybe chapter 6 a little too because of the natural logs. But all this stuff you've seen before. None of this should be like, wow, this is all brand new to me. Like, I have no idea what I'm doing. Like, this is normal stuff. This is AB. Okay? So, hopefully that kind of comes back to you.